Hi guys, welcome to the corrections for week 34 spiral. Let's get started. Monday, Joel has a bowl containing the numbers of colored candies shown in the table. Which of the following probabilities are correct? Select all that apply. So you're going to want to find the probability of each event and make sure that it matches. You have to select all that apply to get it right. Okay, so probability of getting a red, there are 5 out of 15. That reduces to 1/3, which is not the same as 1/4. For the probability of orange, there are 3 out of 15, and that does reduce to 1/5. For the probability of yellow, there is 1 out of 15, which is not equal to 1/10. And probability of green is 6 out of 15, which reduces to 2/5 and is equal to 2/5. Tuesday, determine if each situation represents experimental or theoretical probability. A. Saul flips a coin 20 times and determines that the probability of flipping heads is 0.55. Experimental or theoretical? B. Kelly has made 16 out of 25 free throws. The probability that she will make her next free throw is 64%. Experimental or theoretical? C. There are 4 pennies, 2 nickels, 5 dimes, and 5 quarters in a jar. The probability that a randomly selected coin is a penny is 1/4. Experimental or theoretical? So for the first two, there were experiments performed. They actually did trials to find the probability, so that's why they're experimental. But on the third one, it is theoretical because it's just taking your total number of outcomes of all the coins in the jar and finding the probability, which is 4 out of 16 and 1/4. Wednesday, A. Mr. Skeels will choose one student from each of the 2 groups to present their history report to the class. Which of the following represents possible outcomes? Make sure you select all that apply. This is a tree diagram problem. So I went ahead and made a tree diagram, and group 1 were the trunks of the tree, and I branched off group 2, and the only one that didn't work was Antoine and Greg because they are both from group 1. B. At a restaurant, 1 out of every 6 kids' meals wins a prize. Determine which probability models could be used to simulate winning a prize. Again, you need to select all of them that apply to get it correct. Okay, so the only 2 that work are the last 2 because you need to simulate that 1 out of every 6 kids' meals is a winner. So you need 6 options and then 1 of them to be designated a winner. So the first one doesn't work because the win to loss is just 1 out of 2, not 1 out of 6. Thursday, A. A restaurant has 24 different lunch combinations. Which of the following could describe the lunch options? Select all that apply. So this is the fundamental counting principle where you take each of your events and you multiply to get a certain number of outcomes. So your outcomes, you're trying to get 24. I went through and multiplied the numbers and found the product, and the first and third one came out to 24, but the second and last came to 28, so I did not select those. B. Hat Shack sells 9 different styles of hats in several different colors for 2 different sports teams. The company makes 108 kinds of hats in all. Select the correct values to complete the formula below to find the number of different color hats the Hat Shack makes. So over here is the different styles, colors, and teams. And you want to use these values right here to make the equation. So you're going to do that first. Second part, you are going to solve for your variable and answer how many different colors does the company use for hats. Okay, so the way I came up with the equation is if I there's 108 kinds of hats, so that's the total number of outcomes. And with the counting principle, you multiply all of your different events, and then that gives you your total number of outcomes. So 108 outcomes is equal to 9 styles times C colors times 2 teams. Second part, I went ahead and simplified my equation by first multiplying 9 by 2, then dividing each side by 18, and got that it would be 6 different colors. We are halfway through. Here is PJ, and he wants me to stop and hang out with him, but we must move on. Turn the page, make sure you are making full corrections and showing all work for each problem. Number 1, find the volume of this composite 3D figure. So I went ahead and highlighted, we have 2 triangular prisms and a rectangular prism. You're going to want to find the volume of each separately and then combine them. Okay, a little bit of work for this one. So up in the right, we have the rectangular prism, and formula for volume of a rectangular prism is length times width times height. And so I multiplied 8 times 4 times 7 and got 224 cubic inches. Down here is where I was finding the volume of a triangular prism. So the formula is area of the base times the height. So since the area or the bases are triangles, that's base times height divided by 2 times the height of the prism. So 5 times 7 is 35. 35 divided by 2 is 17.5. And then I multiply it by 4 and I got 70. Still not done. One last part right here. We have to add all of the volumes, and I got 364 cubic inches. Number 2, find the surface area of this triangular prism. So first you're going to enter your answer for the surface area of the first triangular prism. So a triangular prism is made up of 2 triangular bases, which is right there, and then 3 rectangles. So you need to find the area of each and then combine them together. So the triangles, I did base times height divided by 2 and then multiplied it by 2 and got 96. Rectangle 1 is 3 by 10, which is 30. Rectangle 2, also 3 by 10, which is 30. And then the bottom rectangle that it's sitting on, 12 times 3 is 36. Add them all together and I get 192 cubic centimeters. Now you are going to go ahead and do the same thing for B. You want to find the surface area of this triangular prism. Okay, so the 2 triangular bases, it's 12 times 5 divided by 2, which is 30, and there's 2 of them, so they are a combined area of 60. Rectangle 1 is 4 by 13, which is 52. Rectangle 2 is 5 by 4, which is 20. Rectangle 3 is 12 by 4, which is 48. Add it all up, grand total of 180 square inches. Number 3, a rectangular hat box has a volume of 5,184 cubic inches. The box is 2 feet long by 18 inches wide. What is the hat box's height? So we're told the volume, we want to know the height. One thing I want to draw your attention to is the measurements. We're given 2 feet and then 18 inches. My hint is you need to convert them to the same unit of measure. Go ahead and enter your answer. I drew myself a picture and notice right here 2 feet, I converted that 2 times 12 would be 24 inches. And so when I wrote my formula for volume of a rectangular prism, it's length times width times height. I substituted my values. I know the volume, it's 5,184 feet, and that's equal to 24 times 18 times x, which represents the height. I went ahead and simplified 24 times 18 is 432. Then I divided by 432 on each side, and I got that it would be G, 12 inches. Number 4, on a scale drawing, the scale is 1/4 inch equals 1 foot. What are the dimensions on the scale drawing for a room that is 15 feet by 16 feet? So I drew a little picture there for you. You know the actual measurements, and we're trying to use the scale to come up with the model measurement. So my hint is you're going to be setting up two proportions using that scale to find an unknown. So go ahead and enter your answer. The correct answer is F. I got my answer because I used the scale that 1/4 of an inch is 1 foot, and I set up a proportion. So 1/4 is 2500ths. I used decimal instead because I like dealing with them better. So I have 0.25 over 1 foot equals x over 16. Remember, with proportions, you want to line up like terms. So I have scale across from scale, model across from model. And so I solved, multiplied and divided, and got 4. I did the same for the other measurement of 15 feet. I multiplied and divided and got 3.75, which is 3 3/4 inches. Congratulations, you have completed your week 34 spiral corrections. Here's PJ and his happy face that I'm done. Good news, guys. After this week, there is only one more spiral for the entire year. So week 35 will be our last spiral for the entire year. I will see you guys, same place, same time, next week.